So now the types of stresses on steel chimney. So first is the stresses due to self weight. Next is the stresses due to lining weight. Next is the stresses due to wind force, and next one is the stresses due to seismic. So these all about the different types of stresses. Now we will discuss one by one from 1 to 3, and we will not discuss the seismic forces. Now first we comes to the stresses due to the self weight. How we can find out the stresses on the self weight? So basically, first of all, we will find out the weight due to self structure. So WS will be the, first of all we will calculate the perimeter, that will be the pi d into, we will multiply the thickness, multiply by the height, and then multiply by the density. So this is the diameter, dia of chimney at that particular section. This is the thickness of chimney, this is the height of chimney, and this is the density, this is the density of chimney. That is generally, density of steel is generally 7850 kg per meter cube or 78.5 kilonewton per meter cube. So this is the self weight of the chimney. Now we have to calculate the total stresses. So stresses is generally Fs equals to Ws upon this volume or area, so force upon area, that will give the stresses due to the self weight. So this formula will become, T से T cancel हो जाएगा, D से D, pi से pi, so this will become H into P, or this is in the kilonewton per meter square, or we can write it 0.785 H in Newton per mm square. So this is the stresses due to the self weight of the chimney. Okay. Now it comes to the our next force, that is the stresses due to the lining. So what will happen here? We will replace this lining . So now we have to find out the stresses due to the lining. So weight due to the lining will be the pi d. D is the diameter of chimney. TL, where the thickness of lining, we generally take it as 100 mm. We generally, and H is the height of lining, and this rho L. Rho L is the, again, this is the this density of lining material, generally 20 kilonewton per meter cube is the density of bricks. So here this this will be the WL, and we will place it WL, and this pi d into T. So this formula so this will be the our stresses due to the this weight of lining, and it becomes 0.002, and this HDL. So this will become our formula for this, this 0.0 H upon T in Newton per mm square. So this is the stresses due to the weight of lining. Now it comes to the our next, that is the stresses due to the wind forces. Now stresses due to the, so directly we will find this stresses. We know that our formula, that m upon z into y. So mw is the moment due to the wind, and this pi d by 2 q into t into d by 2 is the, so that is the thickness of chimney. This is the moment due to wind force, and this d is the dia of chimney. If we simplify this, so this will become 4 mw upon pi d square into t. The forces will be the this kilonewton per meter square, or we simplify it, so this will become in the Newton per mm square. So this Fs is the Fw. This is stress is due to the this. So we have got it, the stresses due to the self weight, stresses due to the weight of lining, and stresses due to the wind force. Now we see the how we can combine it to got the worst cases or critical load combination. So generally there may be the two types of generally we use formula. So we first of all we will calculate the maximum compressive stresses. So for that, F max will be the Fs plus Fl plus Fw. Okay, so this will give the maximum stresses, maximum compressive stresses. If we want to find out the minimum stresses, this will be the compressive in nature, and we want to minimum stresses or tensile stresses, then this will become this formula. So that will give the tensile stresses, if any, or minimum stresses. Self weight minus stresses due to the wind. Here we have neglected this weight of lining or stresses due to lining, because when the wind force will act, and it will act as a lateral force, so what will happen? That will not contribute in the stability. So hence we generally neglect at the time of the this minimum stresses. So these all about this is the maximum compressive stresses, and this is the minimum compressive stresses, and sometimes it is if we got it negative, so at that time we called is the tensile stresses. So these are all about the steel chimney. So in this video we have discussed about the introduction, different parts of the chimney, just like cylindrical part, flared part, breech opening, clean out part. After that we have discussed about the breech openings, we have discussed about the this lining, we have discussed about the access ladder, and then after we have discussed about the stresses due to various types of forces, that are the self weight, that are the this lining, and this is the due to the wind, and this is the maximum compressive stresses, which is Fs, stresses due to self weight, then the stresses due to weight of lining, then stresses due to the wind force. And if we want to find out the minimum compressive stresses or tensile stresses, then F minimum will be the Fs minus Fw. So dear friends, this is all about the steel chimney. In the next video we will discuss about the masonry chimney.